Hello everyone. Today we are going to talk about circular queue, part of data structures using C++ course. A circular queue is a type of queue data structure where the last position is connected to the first position, allowing the queue to wrap around. This means that when the last position of the queue is filled, the next insertion will occur at the first position, effectively overwriting the oldest data. Circular queues are useful when dealing with real-time systems where data must be processed as soon as it is received, without having to wait for the queue to be emptied first. Unlike traditional linear queues, circular queues do not need to reallocate memory when they become full, which makes them more efficient. However, implementing a circular queue requires a special approach compared to a linear queue, and extra care must be taken to handle the wraparound case correctly. Here is a simple example of how a circular queue can be implemented in C++. This program implements a circular queue with a fixed size of 10 elements. The enqueue function adds a new element to the rear of the queue, while the dequeue function removes the element from the front of the queue. The implementation uses the modulo operator to handle the wraparound case, where the rear index reaches the end of the array and wraps around to the first position. A circular queue is a type of queue data structure in which the last element points back to the first element, creating a circular arrangement of elements. This allows for an efficient implementation of a queue by reusing the memory space of elements that have already been dequeued. In a circular queue, when the last element is dequeued and a new element is enqueued, the next available space in the array is utilized instead of having to shift all elements to make room for the new elements. For example, if a circular queue has a size of 4 initially, that contains elements 1, 2, and 3, it would look like 1, 2, 3 with an empty last element. When element 4 is enqueued, the front and rear pointers would update to point to the next available space. When elements 1 and 2 are dequeued, the front pointers would update to point to the next available element, and the rear pointer would stay in the same position. At this point, if a new element 5 is enqueued, it would reuse the space previously occupied by element 1 in the front. Hope this was helpful. Thank you for watching.